In this lecture, we'll study the intersection of two surfaces or two bodies with the way of auxiliary second plane and sphere method. So here two examples are given. The first example is the left hand side as the cylindric shape, and on the right hand side a cone shape is given. And the way is how to show the points orthographic way, orthographic method. So the point A is given in the left hand side example. So that point, okay, so that point. And please make attention to the notations, okay. So point is given like a in a top view with A1 dash, and if in the top view is given in one with A1 dash, so in the front view that will be with 2 dashes, and in the profile, okay, so on the left hand side view that is given with 3 dashes. If you have no dash here, like A is, and here will be A1 dash, and here will be A2 dashes. Okay. So, and another thing is the brackets. What's the meaning of that bracket? So let's see this. So this cylinder is given. So that's an X. That's Y. That's Z. So what we have to see first, okay, so that's V view, and that's H, okay, top view, and left hand side view is double view, W, and the cylinder shape in the middle of the cylindric shape, okay, without having this center line, it became like a parallelepiped. Okay, so if you see to the parallelepiped prism shape, so if you see from this side, that's also rectangle. Okay, so that's a rectangle. So that's why when you have this central line, that means that this rotation object is there, and kind of cylinder, and or cylinder with hole inside. Okay, so the central line means rotation object is there, and the central line is here also. And also we are seeing to the top view. So if you see from the top, that's rectangle. So here is a circle shape. Okay, so central line here. The point is when you have point here, point A, so that will appear in the front side, and the front view that will be in the front. Okay, so the cylinder is here, like, okay, you say point here, so that will appear on this front surface, okay, on this front surface. So then how to find it? So we don't know the height of the location, okay, so from the 0 to the Z, the height of the A position we don't know, but that will be somewhere in the front of this. Okay, so how to find? So we can make a line like this. So the location of point A will be somewhere in this line. Okay, so say is given some like here. So we're making a dash point. Okay, so and if A is given like this way, A with A dash, and here no nothing, so that will be somewhere in the front, okay, somewhere in here between this and up to here, okay, somewhere here, this surface, because this one is cylindric object and solid thing, so that will be on the surface, also front surface, that is the front side, okay, so front side of the cylinder. From the top view, we are looking from the top, so that will be front side. And another color, say the green side is back side, behind of the cylinder, okay, so that's green side. And how about here? So that is a everything, see in the front view, that's everything is red side, okay, so the front side, everything front side. So how about here? So if you see from the left hand side, so that is left view, everything in here is front view, okay, everything from half of this front view, and half of this the red green view, that's behind. Okay, so and point A is given in the front, so point A is given here, okay, so point A, and in the front view, okay, the front, so that's why A dash is here. So how will be in here? Again, we'll draw a line. So the height position is already there, and the top position also given. Can make a line like this. Can make a 45-degree angle, and this crossing point can go up. So crossing point give you an point A. Okay, so here that is point A dash, but that is with bracket, that comes with bracket. But what's the meaning of the bracket? Bracket means it's not in the front, okay, so it's not in here, it's somewhere behind, because here the W view is this view, okay, so that from this point up to this point, so we are looking from this side, the top view, and this half is the left hand side view of the object. So that left hand side object is here, okay, so it's kind of rectangle shape, and because of the, if you see from this side, if you see the A is on behind, in the behind, so we cannot see it. So if A is here, you can see easily, but that is on behind, so that's why we have a bracket. Okay, so bracket means backside. Okay, so if you have bracket here, what will happen? Okay, so point A is given, A dash, in bracket, in the bracket. So how will be the point in here? So the bracket means behind, so if this point is behind, so point will be here, A point will be here, and how will be here? So you can make it like this line, so rotate it cross, that's also A2 dash, also with bracket, okay, because that is the position of the, okay, so the cylinder is hides this point, so that's why the position of A is on behind of this view, so that's why we put a bracket. Okay, so whenever, if you have any point here, any points, for example B dash point, the solution can be at two sides, 2 point. Okay, so one is here and another is here. So the solution is like 2 point, but if you see there is no bracket, that means on the visible area, visible surface. So visible surface is this one, okay, and this one. So you have to hide this then. Okay, so B is here. And how about here? So make a line. And you can measure the distance. There is a way, many ways. So you can make a like this, the line, make 90-degree angle, and go up until you met this point. Or another way is just measure the distance from the center, this distance, and put that distance here, make a line, so you can get that the point, the crossing point. So that is B2 dash, and that is without bracket because this side is visible side for left view. Okay, so that profile view. Okay, so that is a same as our example. So A is on behind, so that's why we use a bracket here. And also in the left hand side view, if you see from the left, you will see this. And also A is hidden by the sides of the cylinder, so that's why it has a bracket. But we use a normally we use like this character, small character A, here A2 dash, and here A1 dash here and A2 dash here. Okay, so same thing happening with a cone shape. So here is the way of finding this point B and C, how to find it. So here cone is given, and here the top view, and point B is given somewhere here, okay, B dash point at the center line. I have to find point B. to find point B. So if you see to the 3D space, the cone is something like this shape, and point C is given somewhere here. See, so how we find it? How we find the position of the C in the top view? So from the top view, if you see that this point, the tip is okay, point A, and how we understand this? Okay, so we are making a line passing through the tip and passing through this point C. So C is on the top, on the surface. Okay, so on the surface of the okay, the cone. Let's say B surface. B. That is not a C. B is here. So we are making a red line passing through the tip A and passing through point B, and on the basis of the cone, that will make point N. So N point, where is N point located? N point is located on the base. So what's the base shape? Base shape is a circle, right? Circle. So where is that circle? So if you see from the top view, that circle is this circle, right? So then what we do is point N. To find a point N, I have to find it. So we are making the line passing through point A. So A point is here, A dash, right? So we are making a line passing through A dash and B dash. So this is N dash. So find that N dash in the circle that's from the top view. So we're making a straight line and get that N point. So and draw A dash and N dash in the top view. So make a straight line passing through from the point A. A is here, right, in the center. So that is A. So and B dash is B dash. Where is B dash? B dash lies in between A dash and N dash. So A is and N is here, right? Project it. So A and N. So we'll find point B. So that's a way. That's the first way. And there is another way. The second way is like this. So cone is given. Point C is given here. So what we do is we're cutting it. We're cutting and getting a like this truncated cone. So we are cutting it. Okay, we're cutting with scissors or with a knife. Okay, we're cutting it with a knife. And we're getting this truncated cone shape. So where we see C is located on the edge of this top surface, at the plane surface, and at the edge of what's the edge? Edge is a circle shape, right? So same thing happening with the second way. So cone is given. the center line here. So where is a C? C is somewhere here. Let's see dash. So when we cut this line, okay, the plane with the plane, so we get an edge. Okay, so the location of the radius of a circle. So it's using that radius, we can draw a circle. So this is an edge, and this is a circle. So this C point lies on that circle as represents this edge, real edge. Okay, so point C is here. C, just C is here. That might be in two locations, in here and there, but in here it should be with bracket. But here there are no brackets, so that means in visible face of the cone, truncated cone shape. Okay, so that is the first way, and that is the second way. In case of the points are given in the top view, so same way. Okay, here is given C point in here. What we do is we can make a circle. We draw a circle here with the same base radius. Okay, so that's the radius. And from an edge, if you go up, up to the cone and get this point, make a line, and then this point can be projected to that line. Okay. So if the B point is given, just or C point is given, just make a circle, and so this edge of the circle is here, right? So make a line, and then C point can be translated or projected to the surface. Okay, so same like S dash point. Or the first way is, if the B is given, just make a N line, and then find this end point. So project that end point to the cone front view. Make this line again here by using a tip, and translate B to the up. Okay, so that's the way. Same thing is happening with pyramid or prisms. So here is given triangular pyramid. So three sides are triangle, actually four sides, but one base and three sides. Okay, so triangular pyramid is given, point K is given, so you have to find horizontal projection. So point K is given here. Okay, so K dash, K1 dash is given, and how to find K, or K2 dashes are given. So how to find K1 dash? So we are making using CS tip, and we are making a line, so green line passing through S and K, finding M point. Okay, so that point is done in here, so projected is here. Make this point and in the horizontal projection we can get from this one projected, okay, projected K dash. So how to make an intersection line of two bodies. So this kind of pyramid is given, okay, so 3 sides and 1 base, and inside prism, okay, so parallelepiped or rectangular prism is penetrated. So how to find the intersected lines? Okay, so prism is this one, so this blue color. So how to find the lines? Okay, so these lines from the side left view intersected, and from the front that is a rectangle shape, and from the top this shape. So how to find this? So there is a two ways, same as a cone. First, in this view, we have to make the dots, okay, so the points in the corners, so first corner, second corner. So we are selecting only one half, so another half is symmetric, so that's why the first point is here, second point is here, and third one is here, and point 4 is here. So by using these 4 points, we can get the projections in different views, okay? And the point 1, how to find point 1 in the top projection. So we are using tip, and we're making the blue line. We're finding K dash point, okay? So K dash point is here. So if this one is bracket, so that will be on the behind. So in our case is the prism penetrated, and there is it's cutting front also, and the behind also. So that's the front side, and then that is the back side. Okay, so that is a front side, and that's a back side. Okay, so that's why we are generating 2 points K. So point K2 is here, K1 is here. So the blue one is here, the green one is the behind one. And so the point 1 is lies in this blue line. Okay, so we can project it. Okay, we project it. So point 1 is here, the front one. And also in the green one, 0.5, we set like 0.1 in the front, and same like 0.5 is equal to the 0.1, and that's the 0.5. Okay, 0.5 is here. Same like this. The second point lies in front of, okay, 1, so that's why point 2 is here like this. We can make a parallel line with A, B sides of the pyramid base, and so that is a point K, point 2. And point 4, again point 4 can make a the line, find same way, or can just easily project it to the here. And another second way is to making a plane. So we are cutting with a plane. So if you cut the pyramid, so this one is pyramid, 3-side pyramid. So say the point 4. So point 4 is given somewhere. How to find it? We're cutting it, the cutting method. If you cut the pyramid and from the point 4, so we will get triangle. So make that cutting like this, and then the point 4 is lies in the edge, so that's an edge. Okay, so that just project from the top the position to the cutting, but how to find this triangle, so purple triangle, how to find it. So when you cut like this with P plane, so we will get an edge here, the point, so you can translate to here, to the edge, so here the edge, and here another edge, AS and CS and SB are edges. Okay, so that point also lies on the edge ESC, so that's why the point of this M, or M is here, so Q, say Q is here, so on the edge, same like this. So here the edges, so we can find is using a line method and cutting method, 0.4, 0.3, so on. Okay, that is the intersection of pyramid and prism. There is another example giving us intersection of pyramid with plane traces. So plane traces are given. This one, okay. This the front trace, and that's from the top view trace. So how it cuts the triangular pyramid. Okay, it's 3-side pyramid. So we did a lot. Okay, the parallel lines, like the line passing through the tip of the pyramid from the top view, and we make point 2 here. Okay, and that point 2 is going up like this vertically, and makes point 2 dash here. Okay, so and here we'll find point 1 dash, and that point 1 dash is here. So make a line from there. Okay, so in between 1 and 2, and find point L. So L you can translate to the dawn also. So we'll find point L here, and same like here, we can make parallel line with this one passing through L. Okay, this and that. We'll find point K2. Okay, so K2 dash. So we project it to the dawn and get K dash point. So another point is M. M is that is parallelly to the base shape, so we can get that M point also. Okay. So same thing happening with this right hand side example, and that is to find a true shape of true height of the pyramid, and with using auxiliary axis and auxiliary views. So this is example of intersection of pyramid and prism, another kind of pyramid. So that is 4-side pyramid. Okay, 4-side pyramid. And a prism is base is triangular shape. Okay, so it's penetrated inside a prism, and it's generated this kind of hole. Okay, so inner hole. Okay, so that's inlet and that's outlet. And if you note that the prism is not in the middle, is not asymmetric. Okay, so that's why for in the every edges we are making a points. So we find that points by using a line method. Okay, so point 3. So make a line here, green, and then this point is translated to the dawn. Make a line, and then find a point. So there is a secant plane method. So the cylindric shapes, cones, or rotational object is generally made it like a used a secant plane. Okay, so with a cutting with a plane, and then generated edge is used in descriptive geometry. Okay, so secant plane. What's a secant plane? A plane that section of the sphere or ellipsoid is projected onto. Okay, so secant line. There is a secant line is shown in a green color. To the representation of secant planes, the lines that join two distinct points of a curve. So if you connect to any two points, so that will be a secant. Okay, so for example, here in this example, the sphere is intersected with using a purple color, so we'll generate kind of a circle in any case. A surface of revolution. What's the meaning of surface of revolution? A surface of revolution is a surface generated by rotating of a two-dimensional curve about an axis. Okay, so there will be an x, and that is a two-dimensional shape. Okay, it's two-dimensional curve. So if you rotate this curve along this axis, so you will get this kind of shape. Okay, so that is that's called surface of revolution. The example of surface of revolution, those are torus and sphere. The torus is kind of a like this hole, but inside there is a the shape, the circular shape is rotated along the axis, and there is some distance. Okay, so circular shape is rotated along the axis, but there is some distance. But if you rotate like this half, or the circle along the axis, so you will get a sphere. So we are using second method. So for example, M is given in here in the top view. What we do is we're making a circle by using this M point. So we are putting the needle, the compass needle here, and pencil here, and we are drawing a circle, and that circle can be translated to up, and we make a horizontal line, so that M point can be translated or projected to that line. Or in case of that line is given in the front view, so you are making a plane or the line, horizontal line, until it cuts here. Okay, so that will be make this kind of line. Okay, circle. So an M is can be translated or projected to that circle. Same thing happening with the circle. Okay, so surface. same thing happen. The sphere, sorry, same thing happen might be with sphere. The point, if the point A is given here or in the dome, so make a circle, and then from the edge make a line and project the point A to that line. Or like B is given in a bracket, so that means on the behind, but you can make a find an edge, this edge, okay, so make a circle and then project it to the behind, so that's behind side. If the front is here, that's the front, but that's the behind because we have a bracket.